Good morning, everyone. My name is Emma Cortina. We are bringing you a fun lab today. It does lean more technical, so hopefully we have the right audience for this one with us here today. Couple quick hits right off the bat. Please let me know that I'm coming through loud and clear, and that you can hear me okay. You can see the slide deck on my screen. A Y or a yes in the questions pane would be perfect there. Awesome. Thank you guys so much. All right, great. Again, this is a more technical lab today. The intended audience is going to be admins of Exago involved in the setup and configuration of our REST web service. We're going to talk about all things REST today. I do have quite a few of my wonderful colleagues here to help me with questions. Please feel free to shoot them a quick hello if you feel so inclined. I know you guys are pretty familiar with most of our services team. They would love to hear from you. And feel free, of course, throughout the duration of the lab to submit questions via the GoToMeeting control panel. As you see fit, they will be here in the background to respond privately, and if there are any that are good for the whole group, I will read them out loud as usual. So one last note, I just wanted to let you guys know this might be a little bit of a longer lab. If you're not able to stick around with us for all of it, we're recording as always. You will receive a copy afterwards. You can always find them on our support site. Reach out to your CSM if you're having any trouble there. All right, it looks like a few folks just trickled in, so one last intro. My name is Emma Cortina. Welcome to the lab today. We're going to talk about REST, and I'm going to go ahead and get started. All right, so to kick things off, let's just outline the duration of the content that we have prepared today. Two main focuses broken into three real segments of information. So we're going to handle first configuration of the REST web service for use, as well as a basic session configuration walkthrough. I'll be using Postman for that step. On the second half of the lab, we're going to be talking about the authorization header options and diving into a code example of our Exago key encryption algorithm. That's going to be our recommended authorization method in production. So if you're able, stick around to the end of the lab today. That's probably the key bit of information, but we'll do a little bit of other REST basics before we get to that point, just to make sure we're all on the same page here. Speaking of, I have a few assumptions just to begin this lab. So the first two are not actually mentioned on the slide, but I am assuming some level of familiarity with RESTful APIs, as well as Exago's REST web service. The reason that you'll be using the API for your Exago integration, basics like that, will be discussed a little bit when we're talking about the changes that we're making in configuring a session today. But in the interest of time, we're really not going into great detail about the intention of the API. So that's sort of a bit of assumed understanding prior to this content. Now, next, of course, we're going to assume installation of the web service prior to any of the steps shown today. I'm beginning locally with my web service already installed. The version of the web service needs to exactly match the version of your web app down to the minor build number. And the last two steps that we will not be covering today are the app pool configuration and the identity permissions over the web service install directory. These steps are not relevant to Linux, and they are as such upstream of the starting place today. But of course, if you're working on a Windows box, you can find all these instructions detailed on our support site. The article Getting Started with REST is going to be your best friend for those types of configurations. All right, so let's get started with our web service configuration walkthrough. Now, the first thing that I like to verify is that the web server configuration was done correctly. And we have this handy SOAP page that we can use. So the URL consists of the parts and pieces that you see on screen, nicely broken out and color-coded. We have the server URL, whatever virtual path or alias you've set up for your web service when you installed. Then at the end, you'll just add a /api.asmx. My example locally looks like this. I version all of my API and web app installs with their major versions. So mine might look a little bit different than yours, but probably pretty similar. This test can be particularly helpful in eliminating potential points of failure for a non-functional web service. So the reason that I like to sort of normalize doing little checkpoints like this is that if our calls are failing at a point downstream of this, we can confidently exclude the web server configuration from the list of potential culprits by successfully loading this page. It also has some secondary purposes in just a moment. We'll get to those. All right, so step 2 of our configuration here is to point the API to your Exago Web App. It needs to know where to find the base configuration file for each session so that it's modifying the correct starting place. Now we can do this using an XML config file called webreportsapi.xml. It's located in the config directory of your web service installation. So you'll see we have the physical path that can be different for everyone, and then we're actually in the config directory specifically with the file name following that. The XML tags that we need to modify for a base case use case are going to be the app path and web reports base URL. So pretty straightforward. The app path needs to be the physical path to our web app installation. In my case, again, since I version each of my installs with their major version number and use the default install location, it's pretty straightforward. You can see it right on screen here. Yours might look similar. It might look completely different if you direct the installs to a different location. The web reports base URL should be the virtual directory or alias that you specified when you installed Exago, again, for the web app, not the web API. If you're not sure what this looks like in your environment, you can always navigate to your Exago homepage right in a web browser and just copy the first half of the URL. It's going to be everything except for the page, exagohome.aspx or admin.aspx relatively. In my local environment, I have also changed the write log value from false to true. You can see that right in the middle here. The API logs actually write to the temp directory just like the web app logs. So it makes them nice and easy to find. You can check both files at once if you're not sure where the information you're looking for might be going. The other tag here, I'll just mention it quick. Throw exception on error can be set to true if you'd like to catch exceptions in your application that are thrown by Exago. So in other words, handle the try catch in your own app instead of leaving it to us. Once you've modified and saved this file, you'll want to bounce the web server so that the changes take effect. Don't forget this step, please. All right, now at this point, we can again test our progress. So another one of those checkpoints that I would recommend when you are configuring this for the first time. So if we reload that same SOAP page, we can click Initialize API. It's about halfway down the page. I'll show you in just a moment. And then we're going to click Invoke on the page that comes up next. This is testing the changes that we have just made to the API. So after doing so, you'll want to follow this last step here and delete the file listed in step 3.4 to disable SOAP. We're going to be using the web service for REST, so we don't actually need SOAP enabled. Let me just hop over here. We can take a look. If I reload the page, initialize API is about halfway down, and then we see invoke. So I'm going to go back to my slide deck to show you guys success and failure responses. This is an example of the success response. This is what you're looking to see. If we hop back here, we can see that's our success response that we just saw. It starts with www.exagoinc.com. The failure response looks like this. So if you do see that failure, you're going to want to go back to the file in the config directory of your web API and make sure that you have correctly supplied the app path and the web reports base URL. Okay, we have reached the last step in our web service configuration here. It looks like you guys are all following along pretty well. I don't see too many questions. This step is simply enabling REST, right? So we just disabled SOAP when we deleted that file. Now we need to actually enable REST and tell the host application that it can communicate with Exago using our REST API. So to do so, again, navigate to the web services install directory, this time not in the config directory, one step up, and edit the file appsettings.config. We'll add the key that you see on screen, Exago REST with a value of true, save it, and once again, bounce the web server. All right, just taking a peek at the questions pane. Looks like everybody's doing all right. So now we've reached the fun part. We're going to create and modify a session using Postman. So just a note, I prefer Postman, but Chrome does offer an advanced REST client that works just as well. You are welcome to use any REST client that you're accustomed to for this piece. There is no reason that you have to use the one that I am using here. So let me just explain the process that we're going to go through here. Great. So we're going to mock creating and modifying a session the way that your host application will do every time a user interacts with the element of your host app designed to instantiate an Exago session. We're going to first create the session using a post to the session's endpoint, like you can see in step 1 here. Now at that point, we're going to have the app URL, so you can theoretically dump that right into an iframe if you don't want to make any changes to it. Otherwise, you'll likely store the app URL in a variable and use it after we make a few adjustments to the session configuration. Here, those adjustments are in the form of a few patch calls to modify the session for this specific user. I have chosen to demonstrate patching a parameter value. You can see on step 2, as well as the identity values for storage management, as these are configuration choices that nearly every implementation of Exago will include. Now, this exercise using Postman is obviously more manual and illustrative than configuring a session using code. I find that this makes it a good learning tool, but it's also handy for testing out specific calls or endpoints in your implementation. I have also limited our exercise today to endpoints that nearly every implementation will include, but of course, please understand this is not an exhaustive list of the endpoints that you might use. And again, there is an article with a list of REST endpoints and details on how to use them. All right. So we've got just a couple more slides here, and then we're going to move over to Postman. I just want to talk about the configuration steps prior to actually making a call. First thing we need to do is configure our request URL. You can see that right here or in the example screenshot here. Should look like the virtual path to your API. Again, I versioned my installs, so yours might just say Exago Web API. Finally, we tack on REST to the end, and anything following this point will be our specific endpoints. So for this first call, I want to use the sessions endpoint, so I add one more slash and sessions here. Then we need our headers. So let's talk about this for just a moment. Accept and content type are pretty self-explanatory. This is a JSON API, so our requests and payloads will all be formatted as such. But the authorization header is a pretty major focus of this lab. So we are going to spend just a moment talking about the basic authorization method here, and then several minutes talking about other ways to handle it in just a moment. So for now, we're using the basic authorization, and this OG equals value that you see in both the example header here and the screenshot on the right is actually a base 64 encoding of nothing: nothing. The basic authorization model takes the user ID and REST key from Exago's administration console or base config file, and it base 64 encodes them separated by a colon to create our authorization header value. If there is no ID and REST key configured in the admin console, you'll use nothing: nothing, which happens to come out to OG equals. In the sample code that we're going to look at later, we are not using the basic authorization model. We're using a more complex Exago key encryption algorithm that is recommended for production. I've taken a middle ground approach for the first session configuration that we're going to do, and added a user ID of eCortina and a REST key of my special REST key. So we can auto-generate these in the admin console for you. I chose to just use a readable string for today because when we hop over to the code, it'll make it a little easier to see what has already been encoded and what is the value that I have supplied here. Now, once those are put together with a colon and base 64 encoded, our authorization header becomes basic space encoded auth string, and you can see that in the screenshot here as well. Okay, so we are just about ready to send our first call. Let's head over to Postman. I have done this setup here ahead of time, right? So we don't have to take the time to repeat everything that we just looked at in the slide deck. Our first call is going to be a post to sessions, and I have my headers configured. So if I send this, we're going to get back some data about my session, and I'm just going to take a moment to talk through some of this payload. Just one note, the recommended implementation in production, generally speaking, is to use batch REST calls. Batch REST calls enable me to send multiple calls of different methods and body content all in one. So even though we're not going to be formatting any of our calls this way today, there is a sister lab to this one that you might want to check out for more info there. But for today, we're going to focus on the basics of REST. So let's start with the app URL. Now, I mentioned the app URL before. This string has a whole bunch of data encrypted into it to build the unique string identifying this particular session. If we were to take this URL and dump it right in a browser, it'll open up the web interface for that session. It also invalidates the session, so it can't be reused. For this reason, we don't want to consume the app URL until we're done configuring our session. So I'm not going to launch it yet until we're done with the additional configuration choices here. In an implementation that doesn't require any session modification, you might dump it right in an iframe and you're off to the races. All right, now let's consider a JavaScript API implementation for a moment. It's going to require this API key on the second line. The key looks very similar to the app URL, and it will be embedded into the page as you build it, pulled out with the JavaScript on the client side and sent to an API in the JavaScript library. That's going to initiate the handshake between JavaScript and the server-side session. Again, not the focus of today's session. There is a lot of room for scope creep in this lab, but of course there is a lab on the JavaScript API that you're also welcome to check out. Hopefully we have enough content to build an entire implementation walkthrough with a whole bunch of these labs. All right, so the ID in line 4 is a particularly important bit of data in the payload. It represents a session ID, and we're going to use that for any server-side REST calls so that we can tie the REST calls together. As we know, REST has no state, so we need something to link one call to another and make sure that we're still configuring the same session. The rest of the lines are used more if you're using an iframe-based solution to manipulate what we see initially in the frame. Those are the basics that we're going to need today. The rest of the return payload is not relevant so much for our exercise right now. Going to go ahead and copy the session ID, and we're going to begin modifying our session. So let me just duplicate this tab. We're going to come back and grab the app URL at the end. Again, in an implementation, you would likely store that in a variable so that you can use it once you're done configuring the session. I'll store it in a Postman tab. Now, the first thing I need to do is add my session ID parameter. So I can do that in the params tab. It's going to end up as a URL parameter. So it'll modify our request URL either way. We're also going to change this to a get call. Now, again, we're going to do this a little more illustrative and with extra steps than you would do in code, of course. But bear with me, you'll see why. The other thing I'm going to change is instead of hitting the sessions endpoint, we're going to go to parameters right now. Since I'm doing a get call, it's simply going to read the configuration, my base config file, and tell me what I have there. So I have quite a few parameters already configured. And you'll notice that I don't actually have information here about the parameters. I only have each of their IDs. The way the parameters endpoint works is it becomes parameter slash parameter ID. So I can just copy paste. It's of course going to be case sensitive. So if you want to just type it, just make sure you match the case. I'll send another get call just to show you guys that we can now see the information about this parameter specifically. So this is everything you'd see in the admin console when you set up the parameter, data type, value, prompt text, etc. I'm going to copy this whole payload and change this to a patch call. So we're actually going to send a body through with our patch call this time to affect this parameter, right? So this is the first modification that we're making to our session. I only need to send through what I'd like to change. So I'm going to get rid of everything except for the value. We'll give it a value of E Cortina. Great. Go ahead and send this. Now this gives me a 204, no content. That means it was successful, but there's nothing to return. So just real quick, I'll do a get call to the same endpoint and we can see that the value has been updated. All right, great. Last thing that we're going to do is modify another heavily utilized feature in Exago now, right? So the identity parameters that are used for storage management permissions are pretty mandatory to modify for each session. I'm going to go a little quicker through this part since we are repeating the same process here, but it does look slightly different. So the first thing we're going to do is a get call to the storage management endpoint, and it looks like this. If I send this, I'm going to get back all of the data about storage management. So this one works a little bit differently. There is no secondary endpoint to go into a section of it. It returns all of the information, all of the storage management settings as they exist now. Now, the identity parameters are the piece I'm going to be affecting. I'm actually just going to copy the payload that I'd like to send from a local screen so that you guys don't have to watch me modify this. But we're going to change a couple of these values. So let's go ahead and paste it in here. You can see we can do a direct comparison. I've added a user ID and an owner ID. For the most part, these usually match. I'm also adding a company and I've left the class ID as admin. Just going to change this to a patch and we should be good to go. Now, patching the storage management endpoint returns a 200 and actually gives me an updated payload with anything that I've changed, so I can see those values taken immediately. The last thing that we need to do here is grab the app URL from the first call to launch the session. So let's go ahead and get that from my little tab variable over here. And we're just going to pop this in a browser. So I have an open tab that has Exago Home. You can see there's no specific session here. All I'm going to do is replace the end with my app URL, launch a new session. You can see that this user, this identity storage management user, has access to a different set of reports and folders. If I go ahead and run this user ID report that I'll show you in just a moment, it on the design side only has the user ID filled in, parameter rather filled in. So you can see that that value has been updated. If I open it up, it is literally just the user ID and a page header. So we can see that all of the changes that we made to that session have been taken. I can actually revert us back to the base config and we'll see that this has no value, right? When we did the first get call on that user ID parameter, it had a blank value. So nothing comes up now that I've invalidated the session. All right, so let me just take a moment to make sure everybody's hanging in here. Looks like we're doing okay. Appreciate everyone making it this far with me. The last step that we have here is probably the most interesting. We're going to talk about the second and more secure option for our authorization header, and that's using Exago key encryption. So I'm going to go through the steps high level, and then we're going to break it down into pieces when we look at the code implementation. Right, so the steps to create the Exago key authorization header. The first thing that we do is UTF-8 encode what is called the string to sign. And the first breakdown that we're going to go through on the other side is what makes up the string to sign. So bear with me, we'll get to how that is built in just a moment. That string to sign, once encoded, is then signed with a UTF-8 encoded REST key. So we're using similar components to the basic authorization. We're just using a lot more components. The REST key and the user ID are still both relevant. But one of the biggest differences between the basic authorization and the Exago key authorization is actually right in step 2 here. In the basic authorization, the REST key itself is encoded and passed with each REST call. In Exago key auth, the REST key is used to sign the string to sign, but it is not actually encoded in the encrypted header itself, meaning it's not present in our REST calls in any capacity. This is one of the reasons that we recommend Exago key encryption. It adds just a little bit more security in that particular way. This entire resulting signature is encoded using base 64. We then add the user ID and a colon before the encoded signature. So at this point, we'll have user ID, colon, and a giant string. Finally, Exago key is placed before the encoded string to create the authentication header object. And that's very similar to how we saw basic space OG equals equals, or the base 64 encoded string of the ID and REST key in the basic authorization. We're just identifying the auth method used. All right, so let's move over to an example implementation of Exago key encryption to see this process in action. Let me just hop over to Visual Studio. You guys should all be able to, see my screen. Great. So first things first, this is an example implementation, a minimum viable example. And we are looking at first the web config of my simple host app. I've included the user ID and REST key from Exago's configuration file in the web config of the host app. So that's where it's going to get it from to use it in the Exago key encryption. You can see this is the same local environment that we were just using. It has the same user ID, same REST key, same virtual path, everything's the same. All right, let's hop over to the server-side code. And we're actually going to take a look at this. So I've included some breakpoints so that we can kind of step through it and look at all of the values as they are populated here. And I'm going to run this to kick us off. So we'll give a username, Cortina, consistent with the same user we've been emulating the whole time. When I clicked full UI, it kicked off the Exago implementation here. So we start at step 1. The steps here, this code is pretty nicely commented, so you can kind of walk your way through it, but the steps are very similar to the process that we just walked through in Postman. Of course, we post 2 sessions to kick off the session creation. We're going to patch some parameter values. We've got an extra step with roles here, but we're going to set the identity values through storage management. It's a pretty basic implementation, like I said. Now I want to begin with the call API method. We're going to see this at the beginning of every REST call, and it includes information about building that header. Since we just walked through this, we know that for each of those calls, the authorization call is necessary. So let's step through, and we're going to see that the authorization header is null right now because we have not gone through this process yet. But most of the meat of what we're going to talk about today lives in the get auth method. So I'm going to step over one more time, and we're going to spend quite a bit of time on this get auth method here. All right, so get auth begins on line 157, and we're going to talk about the 4 input parameters that it takes first. You can see them defined in the method header. The first thing that it needs is the type. So this is the method type, pretty straightforward. Because this is our first call, we are instantiating the session. It's a post in this case. The next parameter is the relative URI. This is going to be the REST / the endpoints that you're looking for. You can see it right on screen. The relative URI will be concatenated with the base address on line 161, right, which is the beginning of our request URL to build our full URI. That URI is used in the string to sign. So we're going to come back to this value generated on line 161 in just a moment. The SID is pretty self-explanatory, and of course it can be empty because on the first call we don't yet have a session ID. This will be populated for every subsequent call, of course, because that's the purpose of the session ID. Finally, the object representing the body is going to be built of anything that we need to send with the call, right? It, of course, can be empty as well, because for some calls we don't need to send anything in the body, but when we're patching, we do need to send something with it. So you'll see this populated in just a moment. We use this to take the length down below on line 162, and then payload length built here is used also in the string to sign. You can see that it's 2 right now because the body consists of those 2 curly braces. All right, so we're going to walk through the string to sign now. So on line 167, we actually build this string that I keep talking about. A couple of the parameters supplied to get auth are unchanged and put right into the string to sign. Others are modified in some way, like we've sort of started to talk about, and then added to our string to sign. So let's start with the beginning. Type is pretty simplistic. Again, it's a post here. Now, the absolute path of the URI is generated from the URI that's built on line 161. So you can see that it's simply the alias to your last endpoint. The payload length, again, is built on 162 in my example, and it is just the length of the body representing our payload here. Content type is hard-coded on line 163. This will not change from call to call. Again, it's a pretty self-explanatory header. Now we have 2 additional headers here, the MD5 header and the date header, skipping ahead one to the last input here. These are optional as far as supplying values, but it is not optional to include them in the string to sign. So it's absolutely fine if you want to include blank values separated by the new line characters in your string to sign, but you don't need to set values for these headers to make successful calls, as we saw in our example just before. One thing about the date header, it can be helpful in affording additional security. Supplying a value for the date header will cause the REST API to reject calls if the current time is 15 minutes or more after the time in the date header. So for the purpose of the string to sign, they can both be blank, but it might help you in other ways. And then finally, the session ID itself is included in the string to sign, blank in our case here. Each of the values is required to be separated by a new line character like you see here. And we can see that the entire string built together is just everything concatenated that we see on 167. All right, so finishing up here, just a few more steps on line 169, we take the hash of the password parameter. Now, the password parameter is the REST key from your Exago config file. We can see it, my special REST key right here, and we can actually see it represented on line 160 as well. It's grabbing the REST key from my web config. We keep going on line 170. We UTF-8 encode the string to sign itself and then sign that string to sign with the results of line 169. So again, the REST key is not encoded itself, it's just used, it's encoded and then used to sign your string to sign. Okay, finally on line 171, we base 64 encode the entire resulting string. And on 173, we concatenate it with the user ID and separate the 2 values with a colon. So you can see the user ID is Cortina, and you can see our fancy computed hash string here. If I continue back up to the top, we can see the authorization header generated here. Only difference is that we've added Exago key to the front to build the entire header. I do just want to jump through the steps one more time to see the change. So we're going through it for a second time now. Repeating the process means that we're in that first patch call. So the type has changed to patch. Our relative URI has changed to parameters user ID, and it also includes the session ID parameter. We're going to have a session ID here. And our body is going to be populated with value, the value that I gave the host application in this case. You can also see here that our URI is built a little bit differently because the relative URI has that session ID. But again, when we take the absolute path, we strip off that information. The absolute path will only go from the alias to your last endpoint. Right, so if I remove these breakpoints and let the application continue, we will load up a newly configured session, and you'll see the full UI here. The role that we did apply, I mentioned there was an extra step in this code example. That role locked all of my folders here. Let me just take a peek at the questions. It looks like we're doing okay. So congratulations, you guys made it. The last thing that I want to say is that we have some exciting labs coming up next. I'll hang around for just a couple minutes and make sure that if you're writing a question, you have a minute to finish it and someone to answer it. But thank you guys very much for attending today. This was a fun lab to put together. I hope you guys learned something. If you have any suggestions for topics that you'd like to see us cover, please feel free to fill out the survey. Any feedback at all is really helpful to us in making these more helpful for you guys. So don't be shy. Give us all your feedback. And thanks again. Have a great rest of your Wednesday. Happy reporting.